All right, let's look at example 5. F of u is u to the third power, and g of x is u and that u is equal to 3x cubed plus 1. Okay, they had to write it this way for some reason, right? So, okay, what are we doing with this? They said find f of g prime of -1. Okay, so what does that mean? F of g prime is f of g of x. Okay, so what they are asking us to do is find the composition of function, take the derivative of that, and plug in -1. So we're looking for the slope of a tangent line at x equals -1 for their composite function. So what do I need to find? I need to find that composite function first. So I need to write f of x. I need to write the function f in terms of x. This is so tricky. All right, let me try this, okay? First of all, f of u is u cubed, right? But hold on, didn't they just tell us what u is? Let me get my highlighter. They just said u is 3x cubed plus 1. So are you okay with me if I change that u with that 3x cubed plus 1? That's okay, right? And now if I do that, the input variable is no longer u, it is now x. And I will have what's inside? 3x cubed plus 1. And that needs to be raised to the third power. Okay, so this is that composite function. G went into f. We need to find the derivative of this. Okay, so what is the derivative of this function? That is 3 times 3x cubed plus 1 raised to the what power? Second power. So I took the derivative of the big picture. But now I need to multiply this by the derivative of the inside part, which is 3x cubed plus 1. All right, so next line, the first piece will remain the same, but I'm going to work with the derivative of this inside part. If we look at 3x cubed, that's going to give us 9x squared, right? And the plus 1 will just be 0, so that's it. I'm going to go ahead and multiply these two monomials that I see, 3 times 9x squared, and just put them in the front. 27x squared times 3x cubed plus 1 squared. So this is the derivative. All right. So last thing that we need to do is, didn't they give us a number to plug in? They said, let x be equal to -1. All right, so let's find that. What is g composed with f composed with g's derivative? Oh, it's so hard to say, but you know what I'm about to do, right? We're going to plug in -1 in here. So we are finding the derivative of the composite function, and we're finding the slope of the tangent line at x equals -1. That is what we are doing. Plugging in -1 is easy, but explaining what all that is was confusing. Okay, -1 cubed plus 1, and I'm going to square that. And for this part, let me get my calculator out because it looks like I'm multiplying a lot of different things. Okay, I do 27 times -1 squared, 3, I'll go down. I do 3 times -1 raised to the third power plus 1, and that parenthesis is getting raised to the second power. So the answer is 108. So the slope of the tangent line at -1 must be very steep, right? It's going up like crazy. It's going up 108 over 1. So if we graph it, I'm not going to graph it, but if we were to graph it, we are going to see such a steep line. It's almost going to look like a vertical line. But, all right, that's what this puzzle, see, the way they asked us to do, the way they asked it was very confusing, but it was just putting two functions together, do a composition of function, find the derivative of that composite function, and take the derivative of it. And then lastly, just plug in -1. So that was our fun little example number 5. How about I do another one in this video? How about example 6? A very similar problem. Let f of u equals cube root of u. And let g of x be u, and u is 1 plus 6x squared. Same exact thing. They're asking you to find the composite function, put g into f, take that derivative, and lastly plug in 3. So, all right, I'll go ahead and write down what f of u is first. F of u. F of u is cube root of u, but what I want to do is I want to replace this u with in terms of x. Okay, so I will plug in that orange circled part in here, but you know the input variable is no longer u. The input variable is now x. So I'll say this is f of x, and that equals cube root of 1 plus 6x squared. Okay, so we're done with finding this much. We're done with finding this much. Okay, now we have to find the derivative of this, and that requires some chain rule. So I'll go ahead and rewrite this as 1 plus 6x squared raised to the 1/3 power. Okay, because cube root is same thing as raising something to the 1/3 power. All right, what is the derivative of this? I need to bring down that 1/3, keep everything inside the same, but I need to subtract 1 from 1/3. 1/3 minus 1 is -2/3. So the new power is -2/3. But don't stop there, because now we have to multiply this by the derivative of the inside function. So do ddx of 1 plus 6x squared. All right, give me just 1 second. All right, I came back to finish this. So the black part is all ready. I just need to work with the red part. So let me duplicate this down here and find the derivative of 1 plus 6x squared. What will that be? That will be 12x. All right, which means I can now multiply these monomials in the front. I have 1/3 and 12x. So I can simplify my derivative as 4x times 1 plus 6x squared raised to the -2/3 power. What was the number they wanted us to plug in? X equals 3. So let's plug in 3 in there. So f prime of 3 is 4 times 3 times 1 plus 6 times 3 squared raised to the -2/3 power. I don't know if that's going to be a nice number to write down, but let me try to plug this into my scientific calculator first. If it doesn't come out to be a nice number, then we'll try to simplify this ourselves, okay, by hand, okay? Hey, that's not that nice. All right, how about we do this ourselves? And this must be one of those problems that you had, similar to one of those that you had last week. That was just particularly nasty in terms of algebra. So how about I copy this example 7, just put it on a separate page, because it looks like we're going to have to spend some time simplifying this mess. So, all right, hold on. Let me put a sticky paper here to cover this up. And I'll simplify this myself because the calculator, what it gave me wasn't so pretty. So that is 12, right? Outside I have 12. I have 1 plus 6 times 9 raised to the negative 2/3 power. That is 12 times 1 plus 54 raised to the negative 2/3 power. 12 times 55 raised to the negative 2/3 power. So that is 12 on top of the fraction. And I'm going to send this 5, the 55, to the denominator and write it as 55 raised to the 2/3 power. Now, did they ask you for that? What the? It's not gonna get any prettier than this, really, right? I guess I can write this as cube root of 55 squared. But now I got this from your homework, so I'm gonna go and investigate. Did they want a decimal? I can give them a quick decimal. I can say this is approximately 0.8297. Just out of curiosity, let me double check my work. I want to see if 12 divided by 5th root of, a 3rd root of, (55 raised to the 2nd power will give us the same decimal. Yeah, so it's the same thing, but I do wonder if your homework was asking for a decimal rounded to a certain value, because this wasn't just going to be a pretty number. So, all right, I'm going to go in and take a look at the homework with you in this very video. Where did I get this from? It was one of your homework problem. So 1.7, right? The chain rule problems. Maybe number 10? No. That looks like this is it. This is it. This is where I got it from. Type an exact answer. Let me see. I know okay, so you're gonna have to type up an exact answer. So the form like 12 times 55 raised to the negative 2/3 power. It looks like they're not gonna accept decimals here. So I wonder if I click on similar problem several times, is there a chance for me to see the same exact problem? I don't know, guys. Let me try, because no, they're not going to let me do that. Oh, it sucks, but I know I got this right, so I'll go on. But if you guys have issue with homework number 12, question number 12 on section 1.7 homework, let me know. We can work on it together. The answer is just so ugly. It makes us wonder about whether we were doing it right. All right, but that was example 6. I will show you how to do 7 in another video. And 7 is very similar to what you will do for, actually, maybe not. I'll do number 7 in another video.